Okay, let's talk about naming ionic compounds. In this course, we've covered covalent compounds and ionic compounds. In this video, we're going to be talking about naming ionic compounds. Now, ionic compounds are when we donate electrons. If you remember, so for example, NaCl, if we drew Lewis structures of chloride, sodium, it's ionic compounds is when ionic bonding happens. So an electron is donated to chloride such that chloride gets a full octet, a full valence, and sodium also gets a full valence. Sodium gets a full valence by losing an electron and therefore becomes positive because now there are more protons than electrons since sodium just lost an electron. And chloride becomes negative because chloride just gained an electron and now there are more electrons than protons. Okay? So naming ionic compounds. When you name it, you start off with the cation. Remember, cation is the positive ion, and you end with the negative ion. So, for example, in the case of when we have the anion, we will replace it with the IDE ending. Okay, so I'll give you an example of what this is. Suppose we had NaCl. Okay. Well, first we look for the cation. The cation, by convention, should always be written first, okay? Na, that's sodium, okay? So we have sodium. And we have the anion. Na was the cation, chloride is the anion. Cl is chloride. Chlorine. But because we are naming an ionic compound, we remove the INE and replace it with IDE. Okay, how about Kf? Okay, K is potassium over here, and F is fluorine over here. Okay, so first we write potassium. I hope I'm spelling that right. Yep, potassium, which is the cation, and then we write the anion, which is the element is fluorine, but we scratch the INE and replace it with the IDE, fluoride. So instead of fluorine, we write fluoride. Okay? We write fluoride. Okay? And finally, another example, let's do a magnesium bromide. Okay? There's a 2 beside the Br because there's 2 bromide atoms for every magnesium. This has to do with the fact that each bromide atom is -1 and each magnesium atom is +2. So therefore, to balance the charge, you need 2 bromide atoms. Okay, so magnesium bromide. Magnesium, this is the first element, which is the cation, by convention always placed first, and the negative ion, the anion, bromine, but replace it with IDE, bromide. Okay, so that's naming ionic compounds. We also should talk about polyatomic ions. Okay, what are polyatomic ions? So we've talked about ions of just one element. So, example, a fluorine ion, a fluorine anion, a lithium cation. Okay, but we've still yet to talk about what if it's a molecule but also an ion. Okay, so that's what polyatomic ions are. They are poly meaning several atoms. Poly means several, atomic means, atoms, several atom ions. Okay, so these are ions, these are charged particles that have several atoms. Okay, and you see this very often in chemistry. Okay, so you should go about memorizing them honestly. Oftentimes they will give you a chart of all polyatomic ions, but it's good to memorize these. So you have nitrite, at least memorize nitrate, sulfate, phosphate, carbonate, hydroxide, and ammonium. Okay, definitely these you want to memorize, as well as probably chlorate or hypochlorite. Okay, these are very common polyatomic ions that you see often, and they work in this exact same way as an element, as for example carbon, as like magnesium oxide. You still start off with the cation. So maybe let's go with calcium, and you end with the ion. In this case, it would be an anion, so I'll just choose nitrate. Okay. So for example, this is calcium nitrate. So you would find the cation, calcium, and find the anion, nitrate. Okay. You would also, how about this? Well, no, let's change this to SO4. Okay. Okay. You find Si, which is strontium. I believe this is wrong. This should be SR. SR. Okay, my bad. Strontium, and SO4 would be sulfate. Okay, and you don't add. Sulfate. Okay, you don't add the IDE when we deal with polyatomic ions. That's very important. We're dealing with polyatomic ions. You don't change the IDE ending, okay? You just take the first element, the cation, and then the last element, the anion. Now keep in mind that there is one special polyatomic ion that is positive. So you can have something like this. Okay? And all this means, and you would pronounce this as ammonium, because the first cation is ammonium, and notice how I have brackets around ammonium with a 3, okay? This just means there's 3 ammonium molecules with 1 phosphate molecule, okay? And the brackets need to be around the entire polyatomic ion. Ammonium and PO4, we find PO4 is phosphate, okay? So even easier than naming ionic compounds. They don't have to have the IDE ending, okay? Or, you know, beryllium, let's say we had something like this, BeCO3, okay? The first cation, beryllium, and then CO3, carbonate, okay? You look up to your table, and once you use this table enough, you'll hopefully have memorized these, and you find carbonate, so beryllium carbonate, okay? Let's do some practice questions. We have Na. We go to our periodic table of elements. We find Na is sodium. So sodium. And CO3, well, we know that's, you know, because there's several elements, it has to be a polyatomic ion. Okay, there's several atoms, so it has to be a polyatomic atom. We look for CO3 and we find it. CO3 is carbonate. And we don't add an IDE ending. Okay, it's just sodium carbonate. Okay, another Na, that's sodium. And an OH, okay, polyatomic, so several different atoms, so we know it has to be polyatomic. We go and find OH, it's over here, hydroxide, sodium hydroxide. Okay, Mg is over here, magnesium. And Br is bromine, but we place the I and E with ID, so it's pronounced bromide. You spell it with an IDE ending. This is potassium. Chloride. Okay, not chlorine, chloride. Fe. Okay, Fe we find is iron. Chloride. Okay. Now, in the next video, we'll talk a little bit about using Roman numerals, but I'll introduce it in this video. So it should be 2 here. Okay. The transition metals. What's special about the transition metals is that they can have multiple charges. So unlike, for example, the alkali metals or the alkaline earth metals always have +2, alkali metals always have +1, halogens always have -1, and noble gases don't react. Nope. Transition metals can have several charges, so they can either be +3. I mean, for example, one element. In this example, iron could be +3, +2. You know, copper could be +1 and +2. So they have several different ion states essentially, and this is what you see in 5 and 6. Okay, but we'll go go into that a little bit in later videos. Zinc, Zn is zinc over here, and OH, what is OH? We look over here, and OH is hydroxide. Okay, B is beryllium. You can find it over here, beryllium. And SO4, we look at our table, yada yada. Oh, here, sulfate. Okay. You will notice that ones that end with 8 tend to have one more oxygen than ones with end with 8. Okay, so nitrate has 3 oxygens, whereas nitrite only has 2 oxygens. Okay, so 8 means it has one more oxygen. Sulfite only has 3 oxygens. Sulfate has 4. Same with phosphite, has 3. Phosphate has 1 more oxygen. Okay, there's something I should mention. Hypo means less. So it has 1 less hypochlorite. That means it has 2 less oxygen, because ite is 1 less oxygen and hypo is 1 more or less oxygen. So that's why hypochlorite only has 1 oxygen. Chlorite without the hypo just has 1 less oxygen. That's chlorite. Chlorate has 1 more oxygen, so ClO3. And perchlorate is really just hyperchlorate. Okay, hyperchlorate. So 8 is 1 more oxygen. Hyper is 1 more oxygen, so you get 2 more oxygens. So here is 1 oxygen, 2 oxygen, 3 oxygen, 4 oxygen. Okay, so that's how you might be able to help remember the polyatomic atoms. Cr is chromium, but it's also transition metal, so we will ignore that for now. And Al is aluminum. So aluminum. And S is sulfur. Okay, but it's not sulfur, it's sulfide. Okay. Now keep in mind that it is not sulfate or sulfite, it is sulfide. When you see sulfide with the IDE, it's just the element. Okay, if you see sulfite, it's SO with 1 less oxygen, so SO3. Sulfate is SO with 1 more oxygen, so SO4. Okay. Now let's go into writing names from the formula. Okay, so what we were just doing was writing the formula, the chemical formula from the name, but now we are going to go and write the name from the formula. And to do that, it's really simple. You just find the 2 elements, but there's one extra part involved. Instead of the IDE, you need to how to balance charges. Okay, so for example, if you were given sodium chloride, okay, no 1 is sodium, so Na, and chloride, the INE version is chlorine, which is Cl. Okay, but then you have to look into charges. Well, I know sodium always has a +1 charge because it's an alkali metal, and I know chlorine always has a -1 charge because it's a halogen. So you get +1 and -1. Well, luckily for us, we don't have to change anything then, because the +1 and -1 cancels. But what if we had, for example, magnesium chloride? Okay, so magnesium, we have Mg, and chloride, same example as last time, Cl. Okay, chloride has -1 because it's a halogen, but look, magnesium is in group 2. It's an alkaline earth metal, so it has a +2, 2+. Okay, so magnesium +2, chloride is -1. Well, what do? Well, we need to balance the charges. If 1 magnesium is +2, then how many -1 chlorides do we need? We need 2. Okay, we need 2 negative charges to balance the 2+ charge. So the correct formula would be MgCl2. Okay. Another example we can do, let's say we have sodium. This time we have sodium, and I should write the name. Sodium, and let's say sodium oxide. Okay, so sodium we know is Na and has a +1 charge. But what about oxide? Well, oxide is just the IDE form of oxygen, and oxygen has what? It has a 2- charge, right? Because this is -1. Well, let me -1, -2, -3, -4. Okay, now in this case, the elements in group 14 can be + or -4 because they are in the midway. It's +3, +2, plus 1, okay? So alkali metals plus 1, alkaline earth metals plus 2, group 3 plus 3, group 4 is either plus or minus 4 because they're equal distance away from getting a noble gas configuration. Minus 3, group 5 is minus 3, group 6 is minus 2, and group 7 or the halogens are minus 1, okay? So we had sodium oxide, we know we had sodium, so Na, that's a plus, and oxide is oxygen, it has 2 minus, okay? Once again, we have to balance the charges, but this time we're not increasing the anion like we did last time, doubling chloride. We're increasing the cation. So we need 2 positive charges to balance the negative 2 charge. So we have Na2O. So this would be sodium oxide, okay? And finally, let's have magnesium oxide, okay? Magnesium Mg, oxide is O, oxygen is 2 minus, magnesium is 2 plus. Well, the charges are balanced. We don't have to add, have 2 magnesium or 3 oxide or whatever, right? We just have MgO. This is magnesium oxide, okay? Now let's do some examples. Sodium phosphide, okay, we know it's Na, and we know phosphide is just phosphor, P, but phosphor, you can see over here, is -3, right? -2, -1, so phosphor is -3, sodium is +1, so we need 3 sodiums, 3 + 1 charges to balance the -3 charge on phosphide, okay? Let's do magnesium nitrate, Mg, and NO3, okay? So we know magnesium has a 2+ charge, but what about nitrate? If you recall, nitrate has a -1 charge, okay? It has a -1 charge. Compare how that is different from sulfate, which has a -2 charge, and phosphate, which is a -3 charge, okay? So polyatomic ions will have different charges, and it's best to memorize those charges as well, okay? So magnesium nitrate, -1. Well, how many nitrates do we need? We need 2. So magnesium nitrate would be MgNO3 2, because magnesium has 2+ charges and nitrate has 1 charge, 1 negative charge, so you need 2 of those. Now, also keep in mind that when you're writing the formula, you don't add these 2+ charges, right? The correct way to writing is just writing MgNO3 2, okay? You don't write the charges, but I'm writing the charges to show you what's it like to, the thought process, basically. We skipped 24 because lead is over here somewhere. Let me see. Where is it? Where did it go? Okay, well, lead is a transition metal, so we do not include it. Okay. And let's go to calcium. Calcium phosphate. Well, so we have Ca, and we have phosphate, not phosphide. Phosphide is just a P. It's just a phosphor. Phosphate is a polyatomic ion, okay? And we go look at phosphate. We see that phosphate has a 3- charge, okay? So 3- charge. We know that this has a 3- charge. We know calcium, being in group 2, calcium over here, group 2, has a +2 charge. So this is calcium phosphate. If it is +2 and -3, how do we balance them? Well, we got to multiply phosphate by 2, calcium by 3. So what we get is calcium 3, PO4, phosphate 2. Okay, so this is calcium phosphate. If you were to write the formula for calcium phosphate, this is what you would get, calcium phosphate. Okay, ammonium is NH4+, and sulfate is SO4 2-. Okay, double check on this table. Ammonium, a polyatomic ion that is a cation, meaning it's positive, and sulfate 2-. Okay, so if this is 2- and this is +1, we need 2 ammonium, so we have NH4 2SO4. Okay, it's important to put the brackets around the entire polyatomic ion. Okay, Silver is Ag, and it's one of those transition metals that do not have several charges, so it can only be +1. And cyanide is Cn. Okay. I don't know if that's on the table, but just know that cyanide is Cn minus, and Ag is Ag plus, so they cancel. Okay. Aluminum sulfide. Aluminum is Al. You can see it over here, and it is on the +3, group 3, so +3. And sulfide. Sulfide is the over here, not sulfite, not sulfate, no oxygens, just sulfide. Okay, it has a 2 minus, right? Okay, so we have to multiply sulfur by 3, aluminum by 2 to get aluminum sulfide. Okay, beryllium chloride, Be is 2+, and chloride is -1. So we need 2 chlorides. Okay, and that is basically naming.